Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning the Tableau Expert Full Course. Let's have a look at the agenda for today's session. First, we will learn what exactly is Tableau. Followed by that, we will understand the data connections provided by Tableau. Then we will learn how to create data extracts using Tableau. Moving ahead, we will understand the Tableau calculations, aggregations in Tableau, creating quick table calculations, box and whiskers plots, etc. Next, we will learn each and every single type of charts available in Tableau. Then, we will move ahead into formatting and annotations in Tableau. Then, we will understand how to filter data in Tableau. Followed by that, we have organizing and simplifying data in Tableau. Next, we will understand how to run mapping in Tableau. Then we have the data blending, data sorting, special field types, pivoting data paths, parameters in Tableau. Then we will understand the level of detail expressions in Tableau. Finally, we will enter the most important segment of the Tableau course, that is the Tableau dashboard. After understanding, we put our skills to test using the Tableau projects. And finally, we will go through some more frequently asked but subscribe to the bell icon to never miss an update from Simplilearn.
This is Ben. Ben started a store that sells automobile parts like brakes, exhausts, tires, lubricants, and car interiors. He made a good start with his business and achieved profits. However, as days passed by, along with his growing business, he faced some business challenges. He received orders from a variety of customers with different needs and requirements. For example, the northern states had higher demand for performance parts than others, and the eastern states demanded farm truck parts and lubricants more, and the products on the market unsold. With the unbalanced requirements and economy variations, Ben had a tough time helping his customers with products on demand. He slowly realized he needed something new that can help him tackle the store's problems. What if Ben had a tool that could keep track of his store's inventory and sales? A geographical map that can recognize the demand for various types of products from different regions. A forecast feature that could predict the economic fluctuations in the market and help Ben visualize every single detail visually on one single dashboard. This software could practically solve many business problems and also could identify new opportunities to improvise and grow the business. Such types of software tools are called business intelligence tools, and one such tool is Tableau. Tableau was capable of learning the store's business patterns and running queries against the data to help visualize the flaws and resolve them quickly. Now, let us understand how Ben used Tableau and solved the issues related to his business. Ben collected his store's entire sales data from the previous quarter and ingested it into Tableau. Now, using Tableau, Ben was able to categorize the data based on monthly sales. It took the daily sales and considered it as the x-axis. And then Tableau computed the sales in the store. Now, Ben clearly understood the products that outperformed the sales charts and the products that did not have much demand. Let us elaborate a little. Ben found that the performance parts like sports exhausts, turbochargers, and engine management systems were selling well. With the Tableau forecast feature, Ben identified the demand for performance products in the next quarter. So he raised the prices on a few products that had the peak demand and earned higher profits. In the second forecast report, Ben found no significant elevation, nor a drop in the demand for the tractor parts and lubricants. Apart from this, Ben saw the sales graphs of electronics encountered a drop in the current quarter. Compared to the previous quarter, the sales of electronics, like the music and infotainment systems, were low. To improvise and stabilize the fluctuating sales of electronics, Ben came up with some exciting clearance sell offers on electronic products. Using Tableau's geographic map feature, Ben understood the product demand at a regional level. He found the northern regions were interested in performance kits for their imported sports cars. The eastern regions had good demand for truck parts and lubricants. Using Tableau, Ben could generate various visualizations based on his data and come up with business-oriented decisions. Last but not least, Ben could also monitor his decisions and was able to make some necessary modifications to his business model on the go. Ben is now delighted as working with Tableau is a smooth and efficient process. Today, Tableau is being recognized as one of the best-in-class business intelligence tools because of its powerful and dependable features. Tableau can support and connect to a wide variety of data sources like the cloud, DBMS, Excel sheets, and even get connected to real-time data from websites. And Ben keeps his customers happy using Tableau to solve his business problems. Today, more and more leading business organizations are leaning towards business intelligence tools, intending to improve their business. Upon quite a success in his business, Ben decided to get a detailed understanding of Tableau by enrolling in Simplilearn's Tableau training program, which is led by industry experts who can train him according to the current business and IT standards to make his business even more successful.
So what is Tableau? So before we understand what exactly is Tableau, let us imagine a simple situation. Imagine that you are an office worker and you get some loads of data. Maybe like millions of rows or billions of rows, and you are supposed to extract the insights of that particular data. So what do? You basically load that data into a database and try to write the SQL commands and then try to extract the insights of that particular data. So this kind of approach is basically time consuming and you get exhausted. Now, what if you had a tool which could write all the SQL commands for you in the background, and all you had to do is just to drag and drop the data? Sounds interesting, right? So Tableau is just the same. All you have to do is just drag and drop the data and it will automatically write all the SQL commands you ever wanted to write on that particular data, and it will give you live data interactions and advices for the future. Now with this, let us understand the definition of Tableau. So basically, Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize, and make data-driven decisions in real time with extreme agility and accuracy. Now with this, let us continue with the next topic, which will be about the various versions of Tableau. So at first, we have the Tableau Desktop. So Tableau Desktop is a data visualization application to facilitate you to examine virtually any kind of structured data and generate highly interactive, beautiful graphs, dashboards, and reports within minutes. Once a quick installation, you can tie to virtually any data source from spreadsheets to data warehouses and display information in several graphic perspectives. Designed to be easy to utilize, you'll be working more rapidly than ever before. Next, we have the Tableau Server. It is a business intelligence application that offers browser-based analytics anyone can utilize. It is a rapid-fire alternative to the slow pace of traditional business intelligence software. It is an online solution meant for sharing, distributing, and collaborating on content created in Tableau. What makes Tableau different? It is proposed to everyone. There is no scripting required, so everyone can grow to be an analytics expert. You can grow your deployment as you require it. Train online for free, find answers in minutes and not in months. That's the speciality of Tableau. Now followed by the Tableau Server, we have Tableau Online. So Tableau Online is a business intelligence application that offers browser-based analytics anyone can utilize. As discussed before, it is a rapid-fire alternative to slow-paced traditional business intelligence software. So Tableau Online is a secure cloud-based solution for sharing and collaborating on Tableau views and dashboards. Next up, we have the Tableau Public. So now I want to give you guys a serious heads up if you're a beginner in Tableau. Tableau Public is like an open source. Whatever the data you choose to work on using Tableau Public, it goes to public. So kind of like Tableau Public is not preferable if you want to work on your company's sensitive and confidential data. Tableau Public is a free software to facilitate anyone to get connected to a spreadsheet or a file and create interactive data visualizations for the web. It is delivered as a service that permits the user to be up to and running overnight. With Tableau Public, users can construct amazing interactive visuals and publish them quickly without the help of programmers or IT. It is designed for organizations to facilitate their websites with interactive data visualizations. There are higher limits on the size of data you can work with, and among other features, you can keep your underlying data hidden. And lastly, we have Tableau Reader. Tableau Reader is a free desktop application that you can use to open and interact with data visualizations built in Tableau Desktop. With Tableau Reader, you can filter, drill down, and discover humongous loads of data. Now moving ahead, we have the features of Tableau. So these are the few important features that you might want to consider. Those are the first one, robust security. Tableau takes special care of data and user security. It has a foolproof security-based authentication and permission systems for data connections and users access. Tableau also gives you the freedom to integrate with other security protocols such as Active Directory, Kerberos, etc. An important point to note here is that the Tableau practices low-level filtering, which helps in keeping the data secure. Followed by that, we have the collaboration and sharing feature. Tableau provides convenient options to collaborate with other users and instantly share data in the form of visualizations, sheets, dashboards, etc. in real time. It allows you to securely share data from various data sources such as on-premise, on-cloud, hybrid, etc. Instant and easy collaboration and data sharing helps in getting quick reviews or feedback on data, leading to a better overall analysis of it. Another extremely useful feature of Tableau is the use of time series and forecasting. Easy creation of trend lines and forecasting is possible due to Tableau's powerful backend and dynamic frontend. You can easily get data predictions such as a forecast or a trend line by simply selecting some options and drag and drop operations using your concerned fields. Next up, we have live and in-memory data. Tableau ensures connectivity with both live data sources and data extraction from external sources as in-memory data. This gives the user the flexibility to use the data from more than one type of data source without any restrictions. You can use data directly from data source by establishing live data connections, or keep that data in memory by extracting data from a data source as per their requirement. Tableau provides additional features to support data connectivity such as an automatic extract refreshes, notifying the user upon live connection fail, etc. Next, we have informative view and even the mobile view. One of the key features of Tableau, and the one that got its popularity, is its wide range of visualizations. In Tableau, you can make visualizations such as bar chart, pie chart, Gantt chart, bullet chart, motion chart, tree map, box plot, and many more. Like you name it, Tableau got it. You can select and create any kind of visualizations easily by selecting the visualization type from the Show Me tab. Apart from that, it is capable to represent data in mobile view as well. Tableau acknowledges the importance of mobile phones in today's world and provides the mobile versions of Tableau app. The next and the last feature is that being capable of accessing data from various kinds of data sources. Tableau offers a wide range of data source options where you can get connected and fetch data from data sources ranging from on-premise files, spreadsheets, relational databases, non-relational databases, online cloud data, data warehouses, and many more. So followed by the features, now we'll discuss about the advantages of Tableau. So following are the advantages of using Tableau. First one, it has remarkable visualization capabilities. Of course, the unparalleled capabilities of visualizing information is on top of the list of Tableau's software benefits. Followed by that, we have the ease of use. The tool's intuitive manner of creating graphics and a user-friendly interface allows non-developers to utilize the basic app's functionalities to the fullest. Users arrange raw data into catchy diagrams in a drag-and-drop way, which facilitates information analyzing and eliminates the need for the help of IT department and pattern building. Next, high performance. Apart from its high visualization functionality, users rates its overall performance as robust and reliable. The tool also operates fast on big data, which makes it powerful performance on an important point on the list of the advantages of Tableau. And next is the mobile friendliness. One of our best advantages out of the Tableau benefits is its efficient mobile application, which is available for both iOS and Android. It adds mobility to Tableau users and allows them to keep statistics at their fingertips, as well as supports their functionality that desktop and online versions have. And finally, we have the thriving community and forum. Tableau has a rich community. The number of Tableau fans who invest their expertise and skills in the community is increasing rapidly. Business users can beef up their knowledge on data processing and reporting and get many useful insights in this community. Also, forum visitors are ready to help settle any user issues and also share their experience. Next up, we have the disadvantages of Tableau. The first major disadvantage is the high cost. The Tableau is not the most expensive visualization software, especially compared to such business intelligence giants such as Oracle's and IBM solutions. All the same, the license is quite costly for small and medium companies, which makes it one of the considerable Tableau's disadvantages. Next is the inflexible pricing. Tableau's sales team is not flexible enough to provide case-by-case approach for their customers, ignoring the fact that each company has its own unique requirements for visualization tool package. The Tableau sales model requires clients to purchase and extend license from the start. As a result, a lot of companies that use Tableau arrive at the conclusion that they don't need all their licensed features. They would prefer to buying a set of requirements and scale them if necessary. Followed by that, the next disadvantage is poor after-sales support. On multiple message boards, users complain that Tableau software lacks proper after-sales maintenance. If customer has software performance problem, the support team does not settle the matter by investigating the problem's root and eliminating it. Next, we have the poor BI capability or the poor business intelligence capability. As previously mentioned, the tool provides best-in-class information visual interpretation. However, it lacks the functionality required for a fully fledged business intelligence tool such as large-scale reporting, the building of data tables, and statistics layouts. And lastly, the poor versioning. Only the recent Tableau versions support revision history, while for the older ones, software rolling back is impossible. Now, with the advantages and disadvantages discussed, let's move into the top companies hiring. The companies which are desperately looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Wells Fargo, Capgemini, and many more. Now let's discuss the humongous and handsome salaries offered by these tech giants. So according to Glassdoor, the average salary of a Tableau expert in America is 82,000 grands, and for a beginner it is somewhere around $60,000 per annum, and at the highest rate it is $110,000 per annum. Similarly, the average salary of a Tableau expert in India is 5,06,000 per annum, and for a beginner it is somewhere around 3,60,000, and for a highly skilled, experienced Tableau expert, the salaries range from 8,75,000 per annum.
In this session, we will start with certain exercises which we will perform in Tableau in order to understand some basic concepts. Now, in order to learn Tableau, the basic first step is to import a sample data. So in our case, what we have done is we have imported a sample superstore, which is in Excel format, a sample superstore.excel, which has 3 worksheets in it: orders, people, and returns. So by importing this data into Tableau, first of all, we will create relationships between these sheets in order to identify who all have placed orders and how many people have returned the orders. We will do some analysis on the orders placed by a certain set of people and order returned by a certain set of people. Now, as we have imported the sheet, we will make certain joins. So the first step is to drag the orders table, the order sheet, on the relationship canvas here. Okay, and you can see the data, sample data, the first 100 rows over here. Okay, then now we need to create an inner join with people's table between order and people. Okay, so if you see, it has automatically detected the field names on which the inner join has to be created. So on the order side, you have region, and on the right hand side, which is the people data, you have also a region. Okay, so both these columns are common, and that's how we have made a join between orders and people data. So if I close this box and go and check the people's data, open. So see, the region and the person, these two columns from the people table have now been joined with the orders table, right? So it means that these are the orders in a particular region which has been placed by in this region. Let me show you the sample superstore Excel file. Now this is the structure of the file. You have a sample list of transactions, basically the orders which are placed by customers across multiple regions, south, west of USA, south region, west region. Then you have a list of order IDs which have been returned. So basically the order ID in the returns sheet matches with those orders in the orders table. And then you have the people sheet in which you have region and a person associated with that region, the salesperson associated with that region. Okay, so basically when we are joining orders with people, we are joining that which orders belongs to which region and who's the salesperson associated with it. So what we have done over here is we have made an inner join, means all the orders should belong to particular region and that region is in the people's sheet. And then in the second step, now we will make a left join between returns and orders, not inner join. We will make a left join between returns and orders, and we will make a join using the order ID. Okay, so just edit this, click on left and select order ID as the join column. Now what does left join means? Left join means is that consider all the orders from the orders table and only consider the orders from the returns table which have data, means which are returned. Otherwise show null for the order IDs which are not returned. So if you see, these are the two columns from the returns table and these are null because this is relevant to the order IDs which are not returned, okay, which has been accepted by the customer. But these are the orders for which you see data in the returned and order ID column. It means that these have been returned. Now with these joins in place, please save your book, and now we have our relations created in the Tableau. Now we are ready to create certain reports and extract certain KPIs using this relationship model. Now we'll move to sheet 1. Okay, and first we will place state and person on the rows sheet. Okay, then I'll go to my numbers and put the profit or the, so per state, per person, how much profit I am making as a company. Okay, this is my goal to check. Now sort by highest to lowest. So California is giving me the maximum profit of 76,381, then New York, then Washington. So this is the sorted order in which I have listed my profit in descending order. Now I can also check what are the number of orders placed and check the distinct count. So out of 120, out of the total orders of 127, okay, so this is the total number of orders which have been returned for California is 127. It's 16, 29. So the sorted order is as per the revenue, as per the profit, and this is the details of the orders which have been returned per state. So if you see for Connecticut, for Kansas, there are 0 returns. So you can also extract data. Table to refresh is orders and identify new rows using order date. So as and when new data is being added, you can refresh it. Now say extract, and now you can save this information, profit by state, and click save. So this is the extraction of this particular report which is possible in Tableau. So this is the first exercise which we have completed for reviewing and analyzing the profit per state, highest to lowest, and within that per state, what are the number of orders which have been returned by all the customers, the distinct count of order IDs which have been returned. Now let's start our second exercise on creating calculated fields in Tableau. Now in this exercise, we will be doing certain activities, like we will be creating a set to show the states which have more than 100 customers. Then we will be creating a calculated field to show an average sales per customer. Okay. Then we will create a calculated field to show the sales goals, and then show emerging and developing states. So these are the 4 KPIs which we have to derive. Now, the first thing, we have our sample superstore data already imported and the relationships created, inner join with people and left join with returns. Now we have our sheet 2 in which we will create the states, a list of states which has more than 100 customers. So what we have to do is we have to right click on the customer name and click create set. Okay. Now we have to give the name as states with 100 plus customers, and then go to the condition tab, select by field, and then apply condition as count of customer name greater than equal to 100 and click OK. Now we have this set created, states with 100 plus customers. Now to determine average sales by customer, we have to now create a calculated field. So go to the analysis and click on create calculate field. Okay. Now name it as average sales per customer, and now we will say average we will use a Okay, so we are saying that per customer, we are using a level of definition function include, which means that per customer, what is my average sales, right? We've already used a function, aggregated function called average. So we are saying per customer, give me the total and then give me the average per customer. So we're going to click OK. Now create another calculated field. You can also create from here and name it as sales goal. Now in this we are going to type the formula if minimum states with 100 plus customers equal to true, then sum of sales into 1.3, else average sales per customer into 100. So we are saying that if the customer belongs to the set of states with 100 plus customers, then the sales target should be 1.3 times the actual sales as of today, else it should be 100% of the average sales per customer. Now let's create another calculated field which we call as emerging or developing state. If distinct count of customer name is greater than equal to 100, then the state is tagged as developing state, else it is called as emerging state. Okay, so we have now 3 calculated fields: average sales per customer, emerging or developing state, and sales goals. Now we will use this in our reporting. So we will drag sales goal under the columns and then I'll drop my state. So now this is the state wise sales goal, depending whether the state has 100 plus customers or not. Then add your customer name. Make the measure as count distinct and make it as discrete. Okay, so if you see this, we have the count of customers per state and the sales goal for that particular state. And now I'll put my sum of sales, the total sales which I want per, which is there per state. Now go to show me and select this particular chart, bullet graph. Now to bring sales goals to column, right click on the sales axis and select swap reference line fields. Now from your left hand panel, drag and drop emerging or developing state on the color panel. Okay, so emerging state is the orange one and the developing state is the blue one. And save the sheet as developing and the emerging states. So if you see this, it's an emerging state because its count is less than, the customer count is less than 100. Its sales goal is 57384, but the actual sales is 19511. Okay. So now this is a developing state. Its count is greater than equal to 100 and its sales goal and its sales is exactly the same. It matches. So that's why you are seeing the bar and the blue bar is ending exactly where the vertical bar is. So what we are trying to depict is that whether the state is going beyond its target sales goal or it's behind it. And you can see that using this particular vertical bar, like for example Michigan, its sales goal is 71,952, but its actual sales is 76,270 average sales. So that's why it is above its target and it's a developing state because it has more than 100 customers. So you can even sort by the count of the customers higher to lower. So all your developing state will group from at the top and the emerging states will group at the bottom. Or you can sort by the sales goal. So the orange bar is the sales goal or the blue bar. So depending what sales goal is being derived for each state.
So let me now begin with connecting to data. Now in this particular topic, we are at the end of this lesson. You will be able to understand how you can connect to Tableau data server. You will be able to differentiate between a join and blend. How can you perform a join on a data? How can you blend a data? We will discuss the various connection options available. We will understand how Tableau server works in terms of the Kerberos authentication. All right. We will understand various performance optimization techniques as well, shadow extract, as well as different methods that we can prepare in terms of the data that we want to. Based on that, you can you can have your connection to the database. All right. So that's how you can connect to the Tableau server as well. All right. So that's the very first basic. So the Tableau administrator is the one who assigns the roles and creates these data sources. All right. And you have, Tableau has the facility in order to import different forms of data for the analysis for your ease. And once you're connected to the Tableau server, then you need to select the Tableau server data source. On the data menu, you will need to select the data source to download a local file, a local copy. You can select and create a local copy, and then you can also duplicate a duplicate of that data source will be added up into your data window. So that's how you can connect to Tableau server as well. All right, and it basically promotes various features wherein you can then connect to the Tableau server for your data. So you are in this example, you can see that you're able to connect to the Tableau server as an admin and connect to the sample superstore, and it downloads, it creates a local copy and duplicates all the data in that particular data window. That's how we can see the sample superstore, and you can connect to the server. Next, we're going to also understand what is joining and blending. So before I move on to the presentation slides here, what I'm going to do is I'm going to move on to the environment directly. Let us start exploring these blending and joining features right therein. All right, I'm going to simply just clear these sheets that we have, and let's go back to the connect to data source window. All right. Now, in terms of this is where you're able to connect. You can see the Tableau server. So it's through the server that you can connect, wherein you can specify your server credentials and you can click on connect, and based on that, that's how then you can provide the credentials and log in. All right, now I do not have a server connection wherein I can show that example, but this is how you can click on any of these servers. You will have to type in the URL, click on connect, and then provide the usernames and login provided, and that's how you can connect to your data source using a server option. All right, I'm going to show you the file option wherein you can connect to an Excel, and let us discuss the join and the blending part here. All right, so let me click on Excel. We have the sample super data store here, and in this, when I pulled in order, all right, I pulled in the first sheet. So there are 3 sheets in that particular Excel file. When we pull in order, this is how now you can identify that whatever are, these are the header names, these are the dimensions and measures, that's how it's getting identified. So you can notice all the dimensions are first place. You have all your measures, then you're able to identify the data type and the role, and ABC, which is a contextual value or numeric value, that means it's a dimension with a pound sign. What kind of a data role is it? Tableau is automatically identifying each of these roles as well. All right, even in the metadata, that's how you can see the field names, the field name that you're going to see onto your your view, and the table from which it's going to be getting pulled in from. In this, you can rename in case you want to change the particular name, hide it, alias it, or describe it. All right, so this is how you connect. Now, connections is where you have the option to connect between live and extract. Now, if you connect to live, that means you connected to this particular sheet live. That means any update happening onto your sheets, any kind of updates on the sheet, there is a live connection. It will automatically update your views as well onto your sheets that you're creating. And in case if you select on an extract, all right, this is what it means, that it allows, what it does is it imports that data into the Tableau data engine first. In the data engine where it's going to perform the queries, it will create an extract, and based on these, we can then start using the connections. All right, so what it does is it disconnects. It's more like a small extract, more like a cube if you understand it in that manner. Tableau creates an extract of that file, providing you a disconnected, wherein it allows you to give you a better performance, a better query. That's how you can then work on and start creating and working on these extracts. Now you can refresh these extracts at a timely manner as well. So that is what Tableau extracts are, where it extracts it as a copy of the data and saves it in the engine, and that's how then the performance as well gets better in terms of using, where you can connect to your particular data. All right, so you can work with multiple data sources. Data sources can be of any type. All right, wherein you can edit from the number of lists that you can see. It can be a flat file, a server file as we saw, or the saved one. And we can also then join multiple tables within the data, or we can also blend when it's coming in from different data sources. Then we can also perform a blending. So let me first show you an option for join. Now you can see we have the order table here. When I drag and drop the people sheet as well here, you can see that Tableau has automatically created a join. All right, it has automatically created a join when we have pulled in 2 tables coming in from the sheet. And by default, all right, we have the inner join that Tableau creates. So it creates an inner join here, wherein again you can then click on the join option here, and you can specify and modify the join based on whether you want it as an inner join, which is a default, you want a left join. Now if you see, the right join has been disabled here. Okay, I will show these options here. By default, the right join is disabled by Tableau by default, and to enable that you will have to connect to your Excel sheet in a different manner. I will show that to you shortly. So that's how you can change and you can perform your joins. This is where you can explore and show the join clause. And here again, then you can specify, like you can see a join that's being created amongst the data source, which is region and region people among these 2 data. All right, so it's also showing you the join and whether it is equal to or not equal to. All right, so you can connect to multiple tables, and based on that, you can add in tables, you can specify the different joins, and based on that, then when you click on sheet, you will then be able to see that there is a join being performed. There are two tables now, the people's table also that has been added in, and it has now performed an inner join on our data, and you can start using this particular option. So let's say I'm going to pull in the region on my columns, and I'm going to have my sales onto my rows. It's now providing me details of my sales at a regional basis. Now, let's say I also want to analyze the people belonging to these regions depending on the color. So it's going to change the colors based on the central, east, south, and west. All right, that's how these are the people, number of people belonging to each region that it has identified. So that's how it has taken up the region people. As you saw, there was a join that was created, and it's given us that particular option. And based on that, you can see here we just have this particular data source here. And that's how you can see. Now, I've used it earlier as well. If you remember, we had pulled in one particular table. Hence, the blue tick mark sign here enables and shows us that this is the primary data that's being used. Now, this comes in picture when we're using a particular join. So let me right now just use this particular detail here, and we're not going to require this. All right, so let's just close this. We just need one right now because we're discussing on blending. I'm going to show you the blending part later. Right now we're discussing on joins. So that's how you can join in your data sources, and you can combine multiple fields using these joins. So when you have multiple tables, you can simply connect to the data. Let me go back to the data source page. This is the starter page, the data source page. And you can see the joins that's being performed. Now, let's say you want to create a join where you want to force, due to certain situations and scenario where you want to force a right outer join, all right, or right join, or for that matter, you want to write a custom SQL. Now, you're not able to write a SQL right here in the drag area pane where you can drag and drop your sheets from the Excel file or any kind of a file that you're connected to. For that, and to enable the right join, you will need to connect to your data in a specific manner. So let me open up a new instance of Tableau here. And let me show that to you as to how we can enable the right join, and how we can have our custom SQLs as well. So in case if we want to write in a custom SQL on our view, then how can we perform that initial custom SQL, all right? Okay, so let us connect to our data here. And I'm going to take you on to the Excel file. Now, when I click on the sample superstore here, okay, what we had done is we clicked on open, and that's how we opened up the file, all right, and that's how we could see the sheets. Now, instead of using the open option directly, what I'm going to do is in the drop down, all right, here instead of open, we have an option that says open with a legacy connection, all right. This is what is going to enable us to write a custom SQL where we can specify a query rather than using the entire data source or pulling in the entire table. So clicking on this second option in the drop down in the open tab here, you will be able to see the open with legacy connection. I'm going to ensure that you've selected that, and that's how you will then connect to the data source. And with that, you now have a new custom SQL option that's opened up for you all. This is where you can, once you've connected, you can double click on the new custom SQL, and you can write in your query. You can write in the SQL where you want to perform the query and pull in your data. All right, so you can have your select from, and let's say orders. All right, so that's how you can perform, and you can write in custom SQL, and you can pull in the required data. You can have your required table that you can pull in terms of creating a SQL that you want to pull in and have your data. All right, so you can have your select from the orders and preview the results. So here you can see the orders table has 9,940. We have a preview of the data available in that particular sheet that we pulled in. Alright, and we can now parameters is what I'm going to cover when we come on to that particular topic. So I'm going to leave this for now. So that's how you can write your custom SQL, and you can click on OK, and that's going to pull in your entire data. And as you can see now, instead in the earlier view, I'm going to just switch to the earlier instance of Tableau. You could see the name of the table that I dragged and pulled in. You could see the name order. But in case when we write a custom SQL, then it gives us the name which is written as custom SQL query. Alright, and this is where you can get the information, you can edit the query in case you want to change the results and requirements. So that's how, instead of clicking on open, you click on open legacy connection, and you can have your own custom SQL defined. Now, along with this, alright, when you open and when you click on a legacy connection, when I drag in the people's table here, you can see that even the options for right joins have now been enabled. So by default, Tableau disables the option for right joins, and in case in certain situations and circumstances you want the right join to be enabled, you will in the same manner have to import and connect to your data using a legacy connection, and you will have the right join which is going to be enabled there for you all. So you can have your custom SQLs or the right join in that case which gets enabled, and you can use a custom SQL or a right join. Right? So that was custom SQL. Then joining is where you can, as I mentioned, identify and choose between the clauses and the clause that you want to add in. Right? Now let me show you an example of blending as well. So I'm again going to open a new instance of Tableau. Alright, and with that I'm going to show you the example of blending. So let's say you have you want to join in, and when is the best time, when is the best way that you should use. Now joining is when you have all your multiple tables that you want to join coming in from one data source. Blending would be required when you want to join in multiple tables coming in from different data sources. Or for that matter, you can also blend, even though the tables are coming in from a single data source, there might be instances that you might want to have still perform a blend instead of a join. So let me show that option to you. Alright, so let me connect to the data. Let's connect to Excel, pull in our sample superstore file that we have. We have the order table, alright, and I'm going to go on to the sheets here. Alright, so we have one order, we have one data which is the order table. Now I'm going to again click on add a new data source coming in from the same Excel file, and this time I'm going to have the people's table and move to the sheet. So now if you notice, we can see two data sets here, which is one for the orders and one for people here. And in here, now this is where the blending will take place. This is where you will have a blend automatically when you pull in a view, if there is a common view that comes into picture. Now let's say I'm going to first pull in the order date onto the columns. All right. And as soon as I pull in, you can see that my order table has now got a blue check mark, which has become a primary data source. All right, and now let me pull in sales onto my rows, and from people, let me have from the people's table, let's have region pulled in and added to the colors. So region has become a secondary data set, and now you can see a blend sign, right? A linking or data blending that has automatically been performed on both these two data sets, all right, that we have the order table and the people's table, blue being primary and people which is being secondary in this case, all right. So that's how you can mention. Now in terms of blending, what happens is you cannot specify the joins here in this case. There is a primary and secondary data, and it is automatically blending in the data for you. It is automatically pulling in the data. You will not be able to here select on the kind of join. You will not be able to manipulate the join. So that's how, even though at times you have the same tables that are coming in, as I mentioned, there are times where you might want to perform and change the joins. So that's when you can use the joining table option that comes into picture. So that's the difference between your blending and between joining the tables, right? So you can see this available link, and you can see how it was simple to drag a particular view and pull in data. And here as well, region has been added to the color fill, because of which the legends have been created, identifying all 4 regions present in the data. And it's also letting us know here in the marks that region is coming in from the secondary table. You can see the orange amber tick mark here, and that's how you can identify that region is coming in from the secondary table that's been created. All right. In terms of connecting as well, wherein you can combine and have the joins enabled. Now, depending on the kind of data, all right, going back to the data source, depending on the kind of tables and the kind of data that we have, that's when we can enable and have the joins that we can decide on. All right. So one is you would require and need to have a multiple legacy connection with which you can then define the right outer join. All right, and that's how you can proceed and have additional joins that you can work on. We also discussed how we could create and connect to a custom SQL query. All right, and that is how we could, using the legacy connection, also enable the right outer join, wherein we could then perform a right join on our tables as well. All right, and in case if it's a query, then it gives in the name of the query as a custom query, which is what we saw onto the preview and the extract there. All right. Now, in terms of extracts, all right, now extracts are basically your saved subsets of the data source, which will help you in improving the performance. So instead of, as I mentioned, instead of being connected to a live connection, it is better that we select an extract which creates a subset and stores it in the Tableau engine, wherein it performs the queries, and it takes advantage of this functionality where it is not connected to the original data source. And with this, it can actually reduce the total amount of data in terms of defining and limiting it. So that's how you can create an extract. And let's say once you've created an extract, you can then perform, like I said, you have the edit option where you can edit the additional detailings. You can allow an incremental fetch happening, where then you can refresh the data each time your data is updated. You can provide an incremental fetch. So this can help you in improving your performance. You can take advantage of the functionality in terms of the data source for using the discounts, the distinct counts as well. And moreover, it's more like an offline mode. You're actually accessing your data as an offline access, where it's not directly connected, and you're able to use it like a data, local data. All right, so that is the difference between a live and an extract. So that's how you can make use of the legacy connections as well. So let's go back to the presentation slides and have a recap. Now, these are the joining tables. That's what we discussed, that in terms of the tables that we have, we can join a table and we have various joins available, where it makes it easy for us to analyze the data that we want to view. We can join to multiple tables, and based on that, we can customize the inner, the left, the right, or the full outer join. Now, the full outer join also depends on the kind of data source that you're connected to, all right? So in case of an Excel file, we still do not have the right outer join option, which is enabled. So this possible option, again, when you open with a legacy, depending on the data type, is how you will have the right outer join that you can force and have it enabled. So this would be depending on the kind of data source file also that you have, and you have these 4 join types that you can use in terms of joining tables in Tableau. Now, when would you want to use a join? All right, so a scenario is that you have a sales manager of an online shopping website, and he wants to analyze the customers who have returned at least half the number of orders that they have placed. Now, to fulfill this requirement, he will require a worksheet wherein he can join the orders and the return table on a particular common dimension. All right, so that's how then he can create a join. He can change this between the inner default to a left join between the order tables and the return tables, and based on that, he can then get to know the customers who have returned at least half the number of orders that were placed. All right. Now, in terms of enabling a right outer join, this is taken care of by the Microsoft Jet Data Engine driver. So in case if you all are facing a trouble where you're not able to connect and see that particular option, it's throwing an error. This legacy connection options comes in only when you're using a Microsoft Jet Data Engine driver. This is easily available. In case if you do not have it, you can install this driver, and with this it will enable the right outer join and the custom SQL for us. Alright, to enable the right outer join here, that's how you open it with a particular legacy connection. Now, in terms of a right outer join, we saw an example. We can force and use a right outer join. We can select on a new custom SQL where we can type in and have a custom SQL generated. And that's how we can work on with the SQL, where we can provide the SQL syntax, and based on that, the data source will then be generated. Now, in terms of blending, this is what happens when you have multiple data sources in your view, or when you want to establish a link between them, or you want to blend your data. It does not create a row level join. So in case like the example that we did, although it was coming in from the same sheet, from the same Excel file, but we did not want to create a row level join, then that's when data blending would come in handy. You can use it with the related data across multiple sources that you want to analyze in one particular view. So that's how you can blend your data, which creates a primary and a secondary data. So we saw that in this example, you can see that there's a customer segment, department, and sum of sales, wherein the bars are being created, which are coming in from the primary connection. But in terms of the sales plan, alright, these sales plan are coming in from a secondary data. You can see the amber connection here, the amber line here, that is allowing you to understand and segregate and differentiate that it is a secondary connection. So in Tableau, that's how you can identify, as you saw, that your primary source and you have your secondary source, wherein you can identify and distinguish. You can distinguish between the common fields that are present in your data, and you can establish a connection. In case if it has not established a link, you saw that there was an automatic link, then you can provide a link by explicitly defining a link as well. Let me take you back to the environment. All right, so this was the custom SQL. Now, in this case, in case if there is no link provided, then you can provide a particular link onto your view. You can have the option, if it has not enabled, then you can select your particular, you can see that it has not implicitly defined, but it's giving you an option that there is possibility of linking. So you can explicitly define, you can click on this link and use person as a linking field, and this has also linked in your data with the previous data that you have. All right, so that's how you can define and explicitly mention the way that you can blend your data and you can identify. Another way can also be wherein you can edit the connection in the mapping, and that's where you can perform. So you can go back to your data sources and you can explicitly define, you can identify whether the first rows are the names, whether the rows here are automatically generating a field or not. All right, so that's how you can have these two tables, and you can define the blending whether you want it or not. You can disable the linking as well in case you don't want to perform a particular link. So coming to that, now let us understand, I've already discussed the difference between the joins and blends and where you can use it. So let's have a recap again. Now in terms of joining, joining is a SQL term wherein it's combining two data sources coming in from a single data source. While in terms of blending, it's more about combining two different data sources into one single sheet. All right. Joining is done once at the data source, and this can be used for every worksheet, while blending will be done individually for every worksheet. Okay, and both the tables that are joined must exist in the SQL database. While in blending, it helps us combine the database which is coming in from different sources, different locations. And in case if it's a multi-dimensional source, if it's a cube, then you cannot perform a join. And in terms of blending, you have a primary source and but in terms of a primary source, it cannot be a cube, but your secondary source can definitely be a cube that you can use in terms of performing a blend. All right. So that's how you can optimize your connections. You can select whether you want to have perform a blend on your connections, you want to perform a join depending on the kind of connections that you have, and that's how you can work with them with the different data sources that you have available. We're going to proceed further in understanding how we can create data extracts. Alright, so as I mentioned, the extracts are where you create a subset of your data source. You can extract a particular data, you can save it as a subset, which will help you in performing and improving your query. So instead of the live, you can simply click on the extract, which will create a Tableau extract for you. Alright, so let me just show you, let me take you to the repository, and in that you will be able to identify in my Tableau repository data sources. You can see that we have a Tableau extract here for world indicators. So what it's done is it has created a subset of the world indicators data source, and it's disconnected, it's an offline mode which can allow us to improve the performance. It can be accessed offline as well when you're away, when you're probably traveling, and we can then create an extract where we can keep refreshing it with the original data, and we can then replace it with the content, or we can provide a complete incremental refresh with these. Alright, now extract can also be created from within our data sets as well once you perform. So let's say, let me go back to our view here, and let's have category in our columns, let's have quantity on our rows. Now even here you have the option of going under the data menu where you can click on the extract data. So whatever you've selected, any kind of performances and any kind of the aggregations that you perform, now this is your data that you perform. Now instead of, even though it's a live connection, you can still go to the data menu here and you can click on create and extract a data, which will create a subset. Alright, which will create a subset for you where you can create this data and you can provide the different fields wherein you can select what you want to filter, whether you want to add a specific filter to your field, whether you want to specify the aggregation data for the visible dimensions. This is where you can select the option for the measures to be aggregated. The default, instead of using the default, what is the kind of aggregation that you want to use. So this can allow you to minimize the size of your file as well and increase your performance. You can click on aggregation and you want to roll up the dates to year, to quarter, to month. You can select on the aggregation. The number of rows that you want to allow in terms of the incremental fetch here, you want to provide the incremental fetch for all rows or just the top particular selected rows. So you can select on that particular option. Once you've specified all these detailings, you can then click on extract, and that's going to save the subsequent file in the location that you have saved in terms of the extract, and it will save up an extract for you. Alright, so when you click on extract, it will ask you for a subsequent location of where you want to save it. There is a custom query that we had used, and let's say if we save it on the desktop itself, you can see the save type, which is a .tde, which is a Tableau data extract. And the next time you can start working using these data extracts and you can start performing, where you do not need to then have your custom SQL written in or any other detailings. You can simply use the extract and start working on it. Alright, you can actually restrict the size and improve the performance, and you can perform data extracts on these as well. Alright. And then again, in the data menu option here, you have the option to replace your particular data source. So let's say you have your option where you want to perform incremental fetch, then you can replace the data, or you can upgrade it, or for that matter, you can go to this particular table, you can refresh your data with the connection where you have the additional refresh data. You can view your data, you can duplicate it, rename it. We just discussed how we can create the extract data options as well. So that's how you can perform and see and have an extract of your data. So that was using your data extracts. Now, you can also write custom SQL, so we've discussed that. Let me take you back to the presentation slide and have a recap. So here, this is the window that we saw in terms of the extract, where you can add in the qualifications, where you can narrow down your data even more further. You can select an incremental fetch, whether you want it for all the rows or limit the number of rows to be included in that particular extract. Then we also saw that how we could write a custom SQL. We could open it in a legacy connection that helped us to open up a custom SQL window where we can write down the SQL with the exact data that we want to analyze. This can again help us in improving the query performances, where we can write down and provide an optimized query against our data that we want to use. All right. In terms of the supported data sources, a lot of you all had questions, what kind of data sources are supported. Now, Tableau Desktop is supporting it determines the support depending on the kind of license that you have purchased, all right? So only when you have the required license, it will support the different data source types. And you have a personal edition, which provides you and allows you to use the support for a lot of databases. But it is the professional edition that provides you additional database options that you can connect to. So data such as text files, access files, Excel sheets, and so on, these can be connected through the personal editions. While in terms of a professional edition, the professional license, this is where you can connect other than the personal editions, you can connect to the personal additional databases like your Oracle, SQL, and you can connect to certain more additional connections here, which is supported, 40+ data connections, which is supported in the professional edition. All right, so that's how you can connect to these different connections. Now, also along with that, once you have your server that comes into picture, what a server does is it provides you a Kerberos authentication, which is a supported trusted authentication that it uses in terms of your single sign-on. All right. So what it does is, in this case, is that as you can see, it is a protocol that is provided to trust the authentication between your machines, and that's how it uses a third-party network service called as the KDC, the Key Distribution Center, which provides a secure connection between your desktop and the server machines. And this is supported based on the Kerberos authentication. All right, and that's where it uses only one user authentication, the permissions and the access control. In such cases like the workbooks is going to be now the workbooks and extracts will not be handled by Kerberos, but the permissions and access control, those are the detailing that Kerberos will be handling in terms of your data connection. All right, so basically, if your Tableau server has a Kerberos enabled on your machine with a valid active directory credentials, then what Tableau does is it connects to your server and it completely skips the step of authenticating. So in case, let me take you to the environment. Here in the environment, you can see the server option. And in this, you have the publish workbook. Now, let's say when you've created your workbook and you want to publish it onto your server. Now, this is where it asks you to connect to the server here. It asks you to provide the credentials, and then based on that, it then asks you, once you've connected to, let's say you've connected to your server, it is then going to ask you a sign-on for that particular configuration. Now, if you have a Kerberos environment which is activated, then it's going to skip these basic steps here and it will directly allow you to connect and skip these connections that comes in between. So that is what is Kerberos authentication. All right. So it's a single sign-on method. And once you have that enabled, then you can make use of these. You need to configure your Tableau server with these Kerberos configurations. All right. So it's a 3-way authentication protocol. Now, how this works is a mechanism of mutual authentication between the client and the server is provided with the Kerberos authentication. So when the user logs into the directory, it directly asks for the credentials which are authenticated by Kerberos, And once this is authenticated, a ticket is generated and sent to the user's computer. And then when the user tries to connect to the Tableau server from the desktop or the web browser, the Tableau server authenticates the user and it directly allows us to perform. Now this mechanism is provided before the network connection is opened up between the client and the server, right? So how does it work in terms of a single sign-on? How does it support it? It supports a single sign-on option wherein you have the server configuration, and in this you have a core browse tab where you can define enabling the single sign-on option in terms of the environment where you can connect. Individually you can connect with a single sign-on to connect to the server from your desktop or the web browser. Alright. In terms of trying to optimizing your query, now how can you optimize your query? Tableau adopts various query optimization techniques to improve the query performance. Alright. So what it does is it provides parallel query where it improves the performance speed of the dashboard by performing and providing a capability of executing a parallel query. So in this case, what happens is it executes more queries at the same time. It is independent queries that start at the same time, and hence they are faster and improves the performance. So this is what Tableau does. It provides the parallel query. Next in, it has the query fusion. In this, what it does is Tableau has the ability to reduce any kind of complex or large number of queries into a fewer simple ones. So that's how it again optimizes your performance, right? And then it also has external query caching. In this, it quickens up the process of optimizing your data by processing it into a cache. Alright, so that it does not need to go and hit in the warehouse every time that you require a particular data. So this is possible with the external query caching. So Tableau adopts these various methods. It also has a data engine vectorization wherein it has an in-memory analytics column, and it's a faster query which helps in reducing the extract size and creation time. So based on these, that's how it can improve the performance, and that's how it optimizes these techniques, and Tableau handles and takes care of each of these. So it performs a parallel query by its own. It uses a particular query fashion which is short. It does not, it shortens up all the queries, the external query caching that it uses, and also provides a data engine vectorization where it makes it even more quicker and faster. Now, in order to quicken the process of your loading of data, what Tableau does is it creates and saves a shadow extract file on its own. Alright, what it does is in the repository for you to load your data faster, other than you creating an extract, it takes up the content of a shadow extract in your repository file and it saves it up as a shadow while you're working on the workbook. Alright, and that's where then when you're creating and working based on the legacy, non-legacy Excels or text files or statistical file, it creates a shadow extract file automatically wherever you have your repository. So in case when you're working on something, what it does is in your repository folder, alright, where you have your repository, which is in My Documents, in the data sources, you will be able to see that it provides you a particular extract, that is a shadow extract that's been created, and you can see that it creates a shadow extract right there where you can make use of. Alright, in the background. So this is done automatically by Tableau to quicken up the process. This is something that you do not need to handle by default. The folder, there is a folder that gets created. When you have a proper licensed version, then you will see that in the repository folder, you will have a shadow extract folder. And based on that, that is how you will see that at least the first 5, at least the top 5 shadow extracts will be saved with the .ttde extension, and that's how it uses and replaces the oldest one. So when you have a licensed version in that case, then that's when you will be able to see this extract folder, and this is when it quickens up the entire process.
Let me begin with the next topic, which is calculations. All right. Now, in terms of calculations, these are pretty much, these help us in terms of understanding, in terms of creating an extractful, meaningful result of our data, alright? So sometimes it's pretty much necessary that we make use of calculated fields. Now you've already seen that I've been making use of, we created the ship to date and I created various calculations, and I've been mentioning that, I'm going to discuss these in detail in the next topic when we have, like, we created the primary table, the secondary table, I showed you the quick table calculations. So you're already pretty much aware of how I was using them, but let us understand these in detail now, alright? So let me begin. So at the end of this session, in terms of when we complete this topic, you are going to understand how you can make use of strings, dates, logical as well as arithmetic calculations, how you can work with different aggregation options, how you can make use of the grand totals and subtotals, the quick table calculations which are inbuilt by Tableau, how you can create automatic and custom splits, discovering the ad hoc analytics which is offered by Tableau, and how you can perform the LOD, that is level of details calculation. Alright, so let's begin with the very first topic, how you can work with strings, dates, logical and arithmetic calculations, wherein you can create a completely new field which is not present as part of your underlying data. You can actually create that using a specific formula. There are functions and operators provided. So you can use a string, alright, you can use a date, you can use logical operators or arithmetic calculations, and based on that you can then apply certain functions and operators and finally create a calculation. So you can create these 4 kinds of calculations: the arithmetic, date, string, and logical ones. Alright, so let us understand and explore how we can use, how Tableau provides us various built-in functions wherein we can use a calculated field and create an arithmetic calculation. So we've seen an example where I created a profit margin or a profit ratio in our earlier exercises, in our earlier demonstrations, wherein you can use, let's say when you want to create the profit ratio, we use the sum of profit divided by sum of sales. So that's how we created an arithmetic calculation. Similarly, we can create and use string calculations, alright. So I'm going to show you an example of each of these. And then we can also, we saw right now, I created the dates to ship in the earlier example for one of our views, wherein I used the date calculation where we created the day. And we will also make use of one of these logical calculations to see and understand how we can make use of the if-else, the logical calculation operators and functions, and make use of these calculations. So we have a scenario here. So before that, let me move on to our Tableau environment here. All right, and let me start showing you one of the examples of each that we can use in terms of creating them. All right. And in here, let me quickly create one simple view. So I'm going to add in, my states to rows, and I'm going to add sales to my columns, and quickly create one bar chart here. All right. Now I want to have my, let's say I want to analyze the sales across each state here. All right. But I also want to know the count of distinct items. Alright, so in this case, what I'm going to do is, let me have my product name, alright, because I want to know the count of distinct items. I'm going to right click on the product name here, and I'm going to then drag and drop this to the columns over here, alright, onto the column section. Now, because I've selected the right click option and then dragged and dropped in the product name dimension onto the columns, it opens up the drop field as to how I want to use it, whether I want to use, since I want to use a distinct field in analyzing, alright, it opened up this particular window of whether I want to use a count product name or a count distinct product name. Alright, so I'm going to select the count distinct because we want to distinctly analyze the counts of the items, alright, and click on OK. Alright. What are aggregation functions? Aggregation functions, Diksha, the sum, the average, these are the different aggregation functions. So right now the basic default is sum. Alright, so it's summing up the measure, whatever measure we've selected, that's the aggregation function. So whether you want to sum it up, you want to average it out, you want to use median, count, minimum, maximum, these are all the inbuilt aggregation functions provided by Tableau. Or then you can also use the aggregation functions when you're using calculated fields beyond the ones provided. So those are aggregation functions. Yes, we have a bar chart. I'm going to still analyze and show these details to you further in terms of aggregation. So what I did was, instead of just using the product name as it is, I've used a count distinct. All right. Could you please drag and drop the product name? You want me to show that to you once again, Siva? Yes. I'm going to take this off my columns here. Now, when I want to add my product name, if I directly drag and drop it onto the columns, it's just going to add up the details asking me how I want to use it as a dimension. Now, that's not what I want to do, because as per the analysis, I want the count of distinct items, right? So for that, I'm going to simply right click on product name, and then I'm going to drag and drop the product name onto the columns. So in that, it's going to then ask me what is the aggregation I want to use on my dimension. And I want to use a count distinct. So you can see count product name and count distinct product name. So I'm selecting the second option and clicking on OK. Now I want to see the sales per item sold, and this particular field is not available in my data set. So what I'm going to do is I'm going to create one using my calculated field, because I want to see the sales per item. All right. So let me right click on my sales here. All right, in the data pane. So one way of doing it is you can right click, or in the drop down you have the option of clicking on create a calculated field, all right, for that specific field, or in the data pane in the drop down here it says create calculated field. Okay, you can select either option. When you select the drop down from here, it's blank and you'll have to input the formula. When you select a particular field and do it, then in that case, it opens up and adds in the field by default, wherein then you can specify the functions and operators. So let me specify the arithmetic calculation here. So the first type that I'm showing you, the very first option in terms of calculated field, the arithmetic calculation. All right. So let's have our sum of sales, and I'm going to divide this because I want to know sales per item sold. Now that is the reason I've created the count distinct product name here. So Diksha, when you mentioned you're seeing two bars, the only reason I did that was right now I'm just trying to create a count product name, and once I add in the details, I'm then going to replace the particular view from it. All right. So I'm going to divide this with the count product name. All right. So that's how we are creating our sales per item calculation using the arithmetic calculation method, sales per item. So I'm dividing the sales